Okay, let's get started. So I haven't done a roadmap of the homework 2 in a bit, so we're overdue. I don't think I did since the day it was released. So learning objective 1, you have everything you need. You've had this for a while, with the exception of escaping HTML. Those of you who have heard of escaping HTML before, which might be a lot of you, you know what that's about, but this is easy to add after we get to that lecture on Monday. But aside from that, you can do everything else. We've covered everything. Post requests. The polling is already set up for you. We talked about polling. Everything about this you can do. Authentication. We talked about everything with authentication as well. You can register users. You can log them in. Storing hashed salted passwords. Storing hashed tokens. Making sure everything's secure is the biggest thing with authenticated chat. But you have everything you need here. It's more post requests for registration and login, parsing those post requests, and safely storing those databases, setting the authentication tokens. All of that you can happily do. For objectives 1 and 2, getting your database hooked up, setting up your database with Docker Compose. All of that stuff you can do. And deleting a message. This one, honestly, you could probably figure out without me saying anything. But deleting a message, this is one of the things that we'll talk about today. So after today, LO1, LO2, LO3, all on the table. You can do all of those. There's no reason to not get started on homework 2. I know the deadlines are the Monday after content stops for homework, which seems really early. But intentionally, the content is actually out there well before Friday. Next week is doing these cross-site request forgery tokens on Wednesday for the AO. Finishing up the injection attack stuff, which honestly is a minimal change to your code. It doesn't slow you down at all. And then Friday is testing tips and things like that. So you can do the vast majority of this homework. You can do all of the required components of this homework after today. You have everything that you need. And I won't have anything more to say about homework 2 learning objectives after today. No, I can't. Well, with the exception of the escaping your HTML. It's bugging me that my colors are off here. Can I fix these quick? Well, I'm not changing them all. Okay, any questions about homework 2, getting started with it? When to get started was last week, but at the very latest, probably today. Any questions on it? And project, I don't do in a 300 level class, I don't really do my reminders often, but the homework 1 late deadline is the one coming up. You don't need that reminder. Project part 1, we're grading right now. You don't need those reminders in a 300 level class. Let's get on with it. So let's talk about APIs today. This is the content. We're going to talk about a lot of stuff with this content. I used to have students write a whole API with all of the stuff that we talk about in this lecture. For this semester, lots of decision-making went into it, but I decided to just have you do deleting. So you're creating chat messages, and you need one endpoint that's going to delete a chat message. So we're going to talk about the key takeaway that we're going to talk about today related to your homework. So we have data, right? If we have a web app, we're going to have data. We talked about setting up Docker Compose to have your database. We have chat messages. We have user profiles, lots of data. And we're going to have a multitude of other data. If you don't have data, it's a really boring app. You're just going to have, you really don't need a web app. You just need a web page if you don't have data that your users are going to interact with. So our big question, how do we have users interact with data? Let's talk about it. So we have a user who's going to communicate to our server, and our server is going to communicate with our database. How does all this communication go down? And we're going to talk about one kind of specific strategy. The way I frame this lecture, I kind of present it as this is the way you do it. I just want to make sure it's clear. This is one approach to creating specifically a web API and let people interact with your data through an API, through a web interface. So let's start on the server side. How does your server talk to your database? We talked about very basics of interacting with your database, so let's expand on that a little bit more, and we're going to use this beautiful acronym, CRUD. We're going to use CRUD operations. It's generally a good idea to... Oh, I'm getting a spam call. Should I answer it? It's generally good practice to stick with CRUD operations in your database. Sometimes this isn't practical or feasible. Sometimes you want much more complicated interactions with your database. But the more that you can stick with the CRUD operations, the better, and what we say, more atomic your database operations are. If you have CRUD operations for all of your data, you can combine those operations to do all the complex stuff. But if you only build the complex stuff, complex database interactions, there might be things that you just can't do without 100 people knocking on your door saying, hey, can you add these complex SQL statements and give me endpoints for those? So if you stick with CRUD, let people create, retrieve, update, and delete data, they can do whatever they want. You have full functionality with 4 simple interactions with your database. We're going to do 5. I'll sneak in another one later, but CRUD. Create, retrieve, update, and delete. These are the 4 things we want to do with data. What else do you want to do with your data? Create, retrieve, update, and delete. So let's go through these one at a time. Creating a new record, and I'm going to show sample code in both SQL and Mongo, and specifically MongoDB. Of course, MongoDB, but specifically the MongoDB package in Python, which doesn't have any pi attached to it. Anyway, but I'm going to use the MongoDB Python client library syntax, which is insert _1. You can't just call insert. You used to be able to. This is one of my pain points. They changed the interface and removed the insert method. You have to do either insert one or insert many these days. Anyway, this is how you do it in SQL. The old insert into, use your prepared statement. This is usually going to be user-supplied data. In the context of this lecture, it's assumed to always be user-supplied data for these operations. So prepared statements, and then replace those question marks with your actual data. In MongoDB, you would insert using your collection, whatever reference to your collection is. Insert one if you're inserting one record. If you give this a list of dictionaries, then you would do insert many if you want to insert multiple things at once. The way the homework's set up, you're going to be inserting one thing at a time for homework 2, and for all of them. I don't think I ever have you insert multiple documents in one thing. But insert one, and then give it the dictionary. It'll store that as a document, as a BSON document, as it were. But when we create a record, what I really want to talk about with this, the juicier bits that we haven't talked about, is IDs. So even on your homework, every chat message that you create, you should assign it a unique ID. I left this wide open for your homework. I used to require an auto-incrementing integer. I removed that requirement this semester. You can do whatever you want as long as the ID is unique. But in practice, usually it's an auto-incrementing ID for your IDs, for your records. So auto-incrementing, if you're using MySQL, you have an auto-increment that you can just slap on an int, and then MySQL will just do it for you. It just does it all for you. You insert records, you don't even specify an ID, and it'll assign the next int as its ID. IDs, you can start at 1 or 0, fine, but then just increment them for each new record that's created. This guarantees that each record is going to have a unique ID. That's its unique identifier that you can rely on being unique. Since it's an auto-incrementing int, there's no chance, like if you have some random hash function or random values, there's always that chance that you'll have a collision. You won't have any collision here. MongoDB does not have an auto-increment feature. So either you write your own, you have a few choices here. You either write your own auto-incrementing functionality, the strategy for this would be to create a separate collection that's going to store the last ID that was used, initialize that to 1 or 0 if you want to start your IDs at 0. And whenever a record is created, look up in that collection the value of the ID, use that ID, and then increment it and store that back in that collection. So you would have a separate collection just to store this single value for your auto-incrementing ID. And that's a pretty fail-safe solution to this. The reason you need that in a collection, don't store it in a variable. It needs to be in a collection because on server restart, you don't want your IDs to start over at 1 again, because then you're going to have ID collisions, and you completely defeated the purpose of having an ID to begin with. So that does have to be stored in the database, so it's on disk and not in memory, so it doesn't get wiped when your server restarts. So that's one solution. That's decently complicated. It's complicated on top of everything else I'm asking you to do on the homework. I'll say it that way. So this is why I removed the auto increment requirement. So you can do option B, whatever the hell you want. If you can get unique IDs, go for it. You do it. Any way you can get unique IDs, I did. So there was, somebody pointed out a bug in the handout code that I gave you. Because in my front end, I was assuming that IDs were going to be ints, and that's what I tested with. I didn't test with IDs that were strings, and once I tested, I realized how broken it was. So I did update the repo. If you want to pull the new code, all I did was add quotes around the ID in the JavaScript, which generates the HTML, adding double quotes around the value for the ID, if you want to just add that yourself. But if you want to use strings for your IDs, make sure you get that update or update yourself. And then however you want to manage your IDs. I'm going to leave it up to you on the homework. If you ask me what you should do, I'm going to say this, because that's what you should do. It's pretty standard to use auto-incrementing IDs in practice. Unless the IDs are going to be, unless you're worried about leaking information to your users, because users do get some information when you get auto-incrementing IDs. Like they can see how many records they are if they create a new one. They know how many, if you don't want to leak information, you got to be cautious about that. If you're not concerned, this is the standard. But yeah, anything you want for this one, if you think you're going to be clever and use the underscore ID that Mongo creates, keep in mind that that is a binary value. You have to get that into a string somehow, make sure it doesn't break everything. And you have to get rid of that underscore. The front end is expecting ID, not underscore ID. So a few things if you're going to take the common things that people want to do. But yeah, IDs. You have to generate those IDs. You need a way to do it. Whatever you do, get them to be unique. If 2 records have the same ID, everything starts breaking. And somebody deletes that ID number, which one gets deleted? One of them at random, coin flip, both of them, neither of them? I don't know. IDs need to be unique. Okay, retrieve. This is give me every record from the collection, which is our old select star from. If I want to get every record from user or every document from a Mongo collection, is just find and empty dictionary. So find takes a query parameter. If we just say no parameters, it's not going to filter down anything and just give me everything that's in that collection. This is technically called a list operation. If we're getting everything, we're getting a list of all of the records. That's a list operation. So technically, if lists operations are allowed, it's a CRUD database. We have CRUD operations. I don't say that because I just think it sounds dumb. I think CRUD sounds better. I have no better reason. But if somebody, actually is you and says, actually, you have CRUD operations, just tell them that sounds dumb. And you're going to say CRUD anyway, because it sounds better and we generally know what we mean. If somebody says CRUD, I'm going to assume there's a list operation, unless they say otherwise. So we do have 5 operations, not 4. The actual retrieve is going to retrieve a single record. So this is where we get a record with a specific ID. IDs are unique, so give me the record with this ID. Give me the record. We're going to do find one, which will return just one record. So if you're only expecting one record, find one. Otherwise, find, which aside from my rant before, find does still exist. You don't have to do find many for what it's worth. Find one. I'm expecting one thing. That way it's not going to return a data structure. And then you have to say, if data structure size 1, grab the thing, else something went wrong. You don't have to do any of that stuff. This is going to get the record with ID 3 and return that one single record or document since it's Mongo. So that's the actual retrieve. List is when you retrieve everything. The actual retrieve is just getting one record. Update is updating any values we want in the record. A user can update any and all values except ID. I guess I don't say that till my next slide. In SQL, update the table and then set these values, and then where is our filter? So we're updating the record with ID 5 and changing its username and email based on a prepared statement, and we're going to replace these question marks with values provided by the user. With Mongo, we don't have to worry about prepared statements. We just jam our values into the record. Our filter first, where ID equals 5, just like find, we're going to filter out using a query. And then we're going to use this $set. This is a special keyword in Mongo, which means set any of these values. Set the email equal to whatever value we have and username equal to whatever value we have. These can be just spliced right in here from the user, no prepared statements, because the user can't inject any Mongo statements in here. Our Mongo statement is a string, $set, but if they try to do brace $set and then whatever or any other Mongo stuff they want, they can't do that because this whole thing is just interpreted as a string. Because it's just a value inside this dictionary. It will not be interpreted as a dictionary itself. Because we got it over the internet as bytes, we convert it to a string, we splice that string in here, no problems. Whereas if this is a string and we splice it in here, well, the entire SQL statement is just a string. So we're splicing a string into the string. It's not going to work the same way. But that's why we don't have to worry about Mongo injection attacks. This is an actual data structure that we're using here. This is a Python dictionary, not a string. So any Mongo statements that they try to inject are not going to be interpreted as Mongo statements because it's just a value in the dictionary. And you can, case by case, of course, maybe there's some situations where you don't want to, but let users change every piece of value, every value except the ID. Do not let anyone change the ID of a record. That should never change. Records created, it gets an ID, that's its ID forever. If you change that, things are going to break. That's your unique identifier for that record. It's the only thing that must persist throughout the lifetime of that record is its ID, because that's your ground truth of what record this actually is. ID should never, ever, ever change. I'd say if you want to change an ID, first of all, I'd say why you want to change your ID. But I would create a brand new record with the new ID and then delete the old one maybe. I don't know. Don't change your IDs. It's just asking for a bunch of broken links and 404s if you change IDs, among other issues. And then delete. Deleting where, use your where clause in SQL. And then delete one. Delete one is the one time where I'm happy that we have this one versus many methods. Delete one, if I accidentally write a delete statement that applies to a lot of records, it's at least only going to limit the damage to one thing that it'll delete. So delete one, because if you use delete many, which used to just be delete for both of them, and I say forget to add this, and I accidentally give an empty dictionary, I just wiped out my whole collection. So I want to make sure I don't do that. Delete one, delete the record with ID 2 in this case. In practice, you do not have to do this on the homework. I got this question like a million times last semester, which I was happy people were paying attention. But you do not have to do this on your homework. If you want to hard delete on your homework, that's okay. It's not in the testing procedure that you have to soft delete. It means you do not have to soft delete. But in practice, it's common to do soft deletes. It's very, very common to never, ever, ever actually delete anything. All information lives forever. You put something out there on the internet, it lives in some database somewhere forever, is really the way it should work. There are debates about that, of course. If that company is, whoever's controlling that database is irresponsible with that data, yes, there's controversy there. But as long as they don't share that data with anyone who shouldn't have access to it, this shouldn't be an issue. But it's common to soft delete, so we don't actually delete data. We mark it as deleted, and once something's marked as deleted, then that information no longer goes out to anybody. It stays on that database and does not leave that database, or at least doesn't leave the server. Nobody can access that data anymore once it's been deleted. But it doesn't actually delete. We just say, hey, this has been deleted, and then in all of our queries to the database, we say, give me all of the stuff, or give me this thing, give me this, give me that, as long as it hasn't been deleted. Give me all the records in this collection that haven't been deleted. And that's how we'll actually access our database. The one big reason for this is functionality. What happens when a user calls up tech support and says, hey, I accidentally deleted something, can you retrieve that for me? And you say, oh, no, we hard deleted it. Sorry. If you soft delete, you just update that flag. Okay, you got your data back, no big deal. So this gives our users a lot of extra functionality. It also preserves our history. You have a bug that you're trying to debug, and you get access to production data because it's a bug affecting production users, and you look into a user's account and try to figure out where this bug is, what's happening, but you hard deleted all of the things that they deleted. You don't have any evidence of that stuff existing. And maybe that's where the bug was. Maybe there's a bug where somebody tries to update a record that's been deleted, but since it's deleted, you have no history of it existing. How are you going to debug that? That's a tough one to debug, because you legit don't know that somebody deleted something if you delete all memory of it from your database, from your logs, from everywhere. You're not going to debug things. Okay, any questions so far? Last question is about stacks. I don't think that's all. Yep. So a soft delete, it'll stay in the database with a soft delete. You'll just have a flag that says this has been deleted, true. Or more accurately, you'll have a timestamp, a deleted at time. And then if that time exists, you'll set equal to null, and then if it exists, you know that's been deleted. Then you have more information. You have the timestamp of when it was deleted as well. So you get more information about the history of that record. If you hard delete, you actually go into the database and delete it. Like it's gone, like gone. It's similar to files. I can't rely on y'all having OS by now. But it's similar to file systems. If you haven't seen this, if you didn't know this yet, I'll regale you with how this works. An operating system, a file system, when you delete a file, it doesn't actually delete it. It just marks it as deleted. And then that space on the hard drive is free to be overwritten whenever it's needed. But it doesn't actually go and delete any of your data. When you delete a file, it is not deleted. It does not delete it. It just sets a flag. This has been deleted. And then if however the optimization algorithms and everything are working, when your operating system needs some more space, that space is available because it's a deleted file. So if you delete everything off your hard drive and you think nobody can find it, well, guess what? It's all still there. They can delete it. That's why people scrub their hard drives. They'll I think the most effective thing is taking a hammer to it. That's the one I like, and then throwing it in a fire. Nobody's going to read that data anymore. But there's software that will actually delete things off your hard drive. If you're selling an old machine, don't just reformat the hard drive. Make sure you click that erase button at the very least when you reformat, and make sure it actually goes bit by bit through your disk and erases everything, or pull the hard drive out completely. If you don't want people seeing your data. I mean, if all you're doing is dumb stuff, then you don't care, whatever. But When you delete a file, it still exists. It's just marked as deleted. It is soft deleted. Question?
I was just going to ask, is that why, like, when you format one of your flash drives, you can, like, recover data off of it sometimes?
Mm-hmm. And I've done this. I had a corrupt hard drive before, and there's software that'll do that. It will create a whole image, and you'll be able to get things off of it. You can do that with flash drives, too. You can still get stuff off of it, Yeah, when you format, usually there's an option to erase everything, and it'll take significantly longer because it has to go to every single bit. But if you don't choose that option, your data is still there. And my mom actually lost a hard drive. The hard drive died, and I was able to plug it into my desktop as a second hard drive, create an image of it. Like the operating system was corrupt, so it wouldn't boot. But I created an image of the hard drive and was able to recover all of her pictures and everything. It's neat stuff. Computer forensics is the search term if you're interested in that stuff. There's also a class in the business school that they teach about it. It's one of the coolest classes in the business school. Which isn't much competition. I was going to hold back on the jab, but I couldn't resist. For homework 1 resubmission, can we just submit our code to homework 2 since... No, for homework 1 resubmissions, submit again to the homework 1. Well, the homework 1 is accepting submissions again. Submit to the homework 1 project. Your homework 1 code can be in your homework 2 submission, but the TAs won't know to regrade that submission for homework 1. So make sure you're submitting to homework 1, and then the TAs will go through and see any new submissions that have been made after the homework 1 deadline. They know that those are the ones they have to grade for homework 1 regrades. So just a logistical thing, make sure you're submitting to homework 1 again. There won't be a new assignment like homework 1 late deadline. It's all going to be the same. Homework 1, 2, 3, 4. It's just going to be those 4 in the homework category. So you just resubmit to the old one. Okay, so that's how our server interacts with the database, CRUD operations. Keep them simple, those simple 4 or 5, depending on how you count them, operations, and that's it. Unless you have a strong need for a more complicated operation, let people create, retrieve, update, and delete data in list if you want that one. Okay, but how do users interact with our server? Well, HTTP, of course. What else? HTTP, we're going to have 4 different HTTP method types, and those are going to correspond to our CRUD operations. If somebody sends a GET request, they're retrieving or listing data. Post is when they want to create data. Put if they want to update, and delete if they want to delete. Delete's the best named one there. It just immediately says what it's supposed to do. Obviously, that's misleading. These methods are used for many, many other things, these first 3, many other things other than CRUD operations. Delete is the one that just happens to map one-to-one with a CRUD operation. That's why it's named better. Input is going to be a way for users to send data to a server instead of retrieving information from a server. But wait, we already have a method that does that. It's called post. So why do we need put and post? Why do we need 2 different things for this? Oh, I read that backwards. Yes, your homework 1 resubmission can have your homework 2 code. As long as the homework 1 testing procedure still works, it can have all your stuff in it. In fact, December 11th, if you're in that dire situation, you still don't have homework 1 done, and you submit all 4 homeworks, that still is fine. Just make sure you're double checking the homework 1 stuff to make sure your homework 2 stuff didn't break your homework 1 stuff. Especially like when it comes to the 404, I've seen broken 404s after doing more stuff later. So just make sure it's still working. Go through the homework 1 testing procedures again. So why do we need post and put? And the answer, I'll preface this with all of HTTP methods. Like you've parsed HTTP requests before and you've read this method. You and I know that the method is just a string. It's actually just bytes. It's a few characters. This is these 4 characters versus those 3 characters in the header line of the request. There's actually no magic with these. And this is something that took me a while to wrap my head around. Like, there's no magic at all with these methods. There's nothing special about them except the meaning that we as humans add to them. So in all the documentation, all the RFCs, it says if you're doing this, if you have a path, you have an endpoint on your server that it's listening for, and it does these things, you should have it be a put request to communicate that to the people who are accessing your endpoint, that this is what it does. It gives people information about what that endpoint does. But there's nothing magical here. Just like everything else we do, the internet's surprisingly very little magic. I won't say none, but very little magic in the internet. So these are just strings, and then we give them meaning. So when I say this is how puts work, it means if you have an endpoint that works like this, make it a put endpoint to communicate that to the people who are calling the endpoint. But there's nothing magical. Like if you could have a put endpoint, you could say, hey, send put requests to this path, and then you do post stuff on that path. Like no one's going to stop you except other developers who get mad at you and say, why the hell, can you please change that to post? Anyway, here's the difference between post and put, because this is probably the most nuanced difference between any of the two method types. Post means your server is going to do some processing. Put means it's not. Put means you give me something and I just take what you give me and I use that straight up. Post means I have to do some processing first. That's the difference. Put must be idempotent, which we'll talk about a bit here. The reason why creating a chat message when somebody posts a chat message to our server is a post is because we have to generate the IDs. That's the processing that our server has to do. If we let the users choose the IDs, which we shouldn't do, then we would make a put request. For sending a chat message, I just said that one. For sending a chat message, not only the IDs, but also the username. The user is just sending the message. We're pulling the username from the database and generating the ID. That's a lot of processing that we're doing. It's definitely a post request. Bless you. Registration. There's a lot of processing. We're generating a salt, storing a hash, all that stuff. And logging in, we have to generate the auth token, store that in the database. There's a lot going on with both of those. Put, for our update, I didn't put it on a homework this semester, but put, here, update this record. We're just going to update the record with the values we're given. There's no processing to do. We just take what the user gave us and use it directly. Put must be idempotent. I do say must, but there's no magic. If your put endpoint isn't idempotent, nothing's going to explode. It's just other devs are going to get mad at you. Anyone who's consuming your endpoint or fellow devs on your team are going to get mad at you. Like, people are going to get mad. So I say must, but puts should be idempotent, which means sending multiple identical requests have the same effect as sending one of those requests. That's idempotence. So if we send multiple put requests, I say update this record with these values, update the record with this ID with these values, and then I say update this record with this ID with these values, and it's the same ID and same values all three times. It's the same as if I did it once. The values were already updated the first time. Sending the next two requests doesn't do anything different. It's the same as sending multiple identical requests. That's idempotence. And that doesn't mean, and there is a nuanced point here, it means that the data on the server isn't going to change, and the effect of the API isn't going to change. Like the data that it serves isn't going to change. That doesn't mean the response is always going to be identical. You can get different responses on each request, but it won't have any different change on the server itself. The server might tell you something different. The big one here is if I delete a record, the response might be, hey, I deleted that record for you. You're welcome. And then I try to delete the record again. I might get a 404. Hey, that record doesn't exist. What are you trying to delete? I get a different response each time, but the record's still just deleted. It doesn't matter that I set to delete it twice. It's still just deleted once. So get is idempotent. Nothing changes on the server. When we send a GET request, we're just retrieving data. Put and delete are idempotent. putting multiple times. Put can be used to create records. If you don't have IDs that need to be unique, sure. Usually I use posts and generate IDs, but put for updating records, idempotent, updating the same values. Well, I already went through it. Deleting a record twice, same thing as deleting it once. Idempotent. Put and delete should be idempotent. If you're trying to write a put endpoint that's not idempotent, and you're like, I can't get this thing to be idempotent, probably got yourself a post endpoint. Make it a post. Post is not idempotent. Post is indicating to the user, whoever is hitting that endpoint, saying, hey, this is a post. You're going to use the post method. That means when you send that to me, I will make some changes. I will do some processing. There's stuff I got to do to that thing. It is not idempotent. If you send the same chat message in chat for the homework too, send the same chat message from the same user twice with identical requests, that chat message is going to show up in chat twice. Not idempotent. It's going to be twice with two different IDs, two messages, completely separate messages in the database, two separate messages in chat that's retrieved from chat history, not idempotent. Which we don't want chat to be idempotent. Sometimes you say the same thing in chat multiple times. Especially if it's on separate days. Like that's a common feature. We don't want posts to be idempotent, or we don't want our chat messages to be idempotent. And this is what we call a REST, well, I don't know if I can say it that way, but let's talk about RESTful APIs. So RESTful is very loosely defined, or at least loosely understood. It took me a long time to wrap my head around what the hell a RESTful API even is, or what REST is. And to be honest, I still don't 100% know what the hell this means. There's no RFC to define it. This was defined by, I'm blanking on the name, but somebody's PhD thesis. They came up with this, and it's their thesis, which is the documentation for the definition of RESTful. So it's not necessarily structured the way an RFC would be, that's agreed upon through a whole community. It's more loosely defined, I'll say. There's no hard and fast, like, look at the RFC, that is what it is. And there's no real technical details in that thesis either. It's quite surprisingly vague and very high level. So out there in industry, there's a lot of different understandings of what, or expectations of what a RESTful API is. So I'll do my best to give you a footing to stand on to talk about what RESTful APIs are. But let's talk about it. And typically, the way RESTfulness is used is on a spectrum. You don't have an API that's RESTful and an API that's not RESTful. An API can either be more RESTful or less RESTful. And these are verbs that I hear and also use from time to time. Somebody says on your team, hey, can't we just add an endpoint that creates multiple records? I would respond with, well, we could, but it's not very RESTful. If we do that, our API is getting less RESTful at that point. Or, hey, this API is kind of janky, kind of messy. Can we refactor this whole thing and rewrite it to be more RESTful? But there's no objective like it is or isn't RESTful. If you're using the objective measure, I don't know if there is a RESTful API out there, at least not a useful one. Maybe in an academic setting there's one that exists, but not a useful one out there. I don't think there's any objectively is RESTful API. Anyway, let's talk about what REST is, because this is a term you're going to hear a lot. You probably heard a lot if you've done any web development already. If not, you will hear it a lot if you get into any web development. You'll hear this term a lot, and you'll hear it thrown around a lot, and I don't know if a lot of people know what they mean when they say it. And not judging them or anything. Like, each shop is going to use this word differently, and just the way it is, because it's used loosely defined. So one, there's a series of constraints. First constraint has to be a client-server architecture and statelessness. If your API has these two features, you are getting more RESTful. We're using HTTP, which has both of these by implication. So check mark on that. Every web API has this one satisfied. Except the statelessness. Oh yeah, I do want to talk about statelessness a little bit. This is why most APIs are not RESTful, any useful API out there, because there has to be some sort of authentication. If there's authentication in API tokens, you just lost statefulness. The requests themselves are stateless, but you have state on the server, which is changing based on the user's request. And there's, I don't know. I don't feel like talking about it more. There are arguments on the internet you can read, and I've read, and it's just like, we're so lost in the weeds at this point. No, it's not RESTful. No, I don't care. Cacheability, everything should have its caching information, and especially your retrieve request should be cached for better performance. Should have all that cacheability in there. If the information didn't change, it should be cached. Speed. It should be a layered system, meaning we can add layers in between our server and the client, and that shouldn't break anything. We shouldn't need a direct line of communication with the client. There are a few reasons we would have this, a few reasons that we will actually do in this class. The load balancer we won't do, but if you have a load balancer and multiple instances of your API all running and talking to a shared distributed database, that should be allowed. If that's not allowed, you have a less RESTful API. The one we will do is adding a reverse proxy server in front of our server that the client is going to talk to the reverse proxy. The reverse proxy talks to our server and forwards that. And we do this to add encryption onto all our traffic. This is a homework 4 thing that we're going to do. It's the only thing you'll be asked to do on the homework 4 itself, actually. Adding this reverse proxy server. By the time, since I mentioned it, homework 4 is going to be pretty easy. I don't know if I mentioned this in lecture before. It's only one AO task, so 2 AOs total. No learning objective tasks, because at that point in the semester, I want you to have a strong shift towards your group project. That homework 4 content is going to be more group project related. But that's what we'll do in homework 4 on the individual part of the homework. Or your client's using a VPN. If they're pinging their requests off a VPN, the thing should still work. The API should still work. And we need a uniform interface where everything that the API does should be self-documented by the API, and everything that the API gives should be enough. I'm wording this weird, but all the information the API gives should be enough to do everything you want with that API without using any outside resources. So the big thing is when you create a chat message, this is where our API isn't quite RESTful. You have to call chat history. Actually, kind of is. But when you create a record, no, it's less RESTful because of this. When you create a record, send a chat message, you should get a response. Maybe I'll change the homework for next semester to do this, but it should get a response with your username and ID. So when I create a record as a user, I need to know the ID of that record. Anything that the server added to that record, I would like to know that information. If it doesn't, it's not a uniform interface. So the fact that our server for the homework isn't going to respond when we create a record with that record that was created with my username, message, and ID makes it less RESTful. And then we have to call chat history and kind of guess which one is the record that we just created. It's not a uniform interface. So we get minus RESTful points on that one. And as I mentioned earlier, the 4 GET requests correlate directly with our 4 CRUD operations. So the user is going to use our RESTful API to send requests to the server, HTTP requests to the server. Server is going to convert those into CRUD operations to the database. And then if we're retrieving data, we're going to send that back. Or if we're creating data or updating data, we're going to send that back to, create and update, or create and retrieve. I'll get this. Create and retrieve, we should be sending information back to the client with the information that they're either retrieving or the information containing the stuff that we processed as part of the post request. For put and delete, those are idempotent. The user already has all the information, and we're just taking their request and executing it. There's nothing to process. There's no new information to respond to the user, so no need to respond to those ones. But we're not doing a full RESTful API in the homework. Maybe I'll add it to homework 4. No, it's too late to do that. But What does idempone mean? Oh, goodness. It means sending multiple identical requests are going to have the same effect as sending one request. It's my abbreviated one. I spent way too long already talking about it, though. And how much time do we have? 4. I'm going to try to do this. Any questions about CRUD, REST, database stuff? Specifically if it has to do with delete, because that's the one part of that I'm asking you to do. Okay, let's go over authentication. I added some visuals. I probably won't get through these, so if you want to take a look at these, they're on Wednesday's slides. I added them. But I want to go through just the whole registration and login process visualized. So let's do it. So a user wants to create an account, and so basically all of LO2, create an account and log in. What do you have to do? So a user's going to create an account. When they register, username and password, plain text sent to the server. The server is going to generate a random salt with a lot of randomness. It won't add entropy, but the salt itself should be pretty large to make sure we don't have any rainbow table attacks. We're going to append that salt to the end of the password and hash that whole password and salt. So this is a salted password, and then this is the salted hashed password. So we have a hash of the password and the salt. I said that in bullet points quite a few times, but to visualize it, we're going to append the salt and then hash. That gets our hash that we're going to store in the database. And then in the database, what we're going to store is username, salt in plain text, and that salted hash of the password. Do not store the password in plain text. Hopefully nobody does that. I've said that so many times. Never store plain text passwords. If you're using bcrypt, which you're going to use on your assignment, unless you want to build all this stuff from the ground up, if you want to do a whole bunch more work, fine. But if you're using bcrypt like I recommend, this will all be one value. Bcrypt will add the salt and the hash in a single value, where it starts with the salt and then goes into the hash. And bcrypt knows how to separate the salt and hash out of this single value. So you only store one value. It adds actually 2 things, but it's one value that you're responsible for storing in your database when you're using bcrypt, which is convenient. User wants to log in. They give their username and password again. Ooh, that's identical slides. The server is going to take that username, ask the database for the record for that username. If we get a record, if we don't get a record, the account doesn't exist. We pull the record from the database, and then we take the password that they gave us for login and the salt that we stored in the database, append the salt, compute the hash, and if the hashes match exactly, then and only